Welcome back for the third week, and I'm really excited to have you back. Come again and for this week as well. And this week we're going to be looking into deep learning models in production. So last week when we started, we kind of last week when we finished at the point where we were at that point where we could get our data sets ready. And this week, what we're going to do is we're going to build on top of that. We're going to have our data sets ready, and on top of that, we're going to also learn how to create a deep learning model. And more specifically, we're going to learn how to put that model in production. So we're going to create an application that you and everybody else can then share with your friends, and you can share what work you've done. And then we really want to, at that point, we really want to start sharing our work, because that's something that's really helpful. And you want to start sort of writing blog about it, or sort of sharing that on social media. But we'll talk more about the benefits of each in a while. But then again, a lot has happened this week. So Ravi Chandra, he's also written a blog just this week. So thanks, Ravi, for sharing all the learnings and sort of summarizing everything that you've learned. It's really good, and I really did kind of notice your profile just because of that you've been sharing this week after week. And it's really exciting to see that you're working as a software engineer, but yet your interest in deep learning seems to be quite a bit. Same for Korean. He's come back again for the second week, and he's again written another blog, which is more about a summary of what he learned last week. It's really helpful, and I think this is something that I believe both you, Korean, and Ravi, you both would have learned a lot by writing, just by sort of summarizing and writing everything and summarizing what you've learned. Exciting news. Next week, we're going to have Parul joining us. She will be sharing exactly about this. She will be sharing about how to share your work publicly. So if you don't know about who Parul is, let me show you. So Parul is a notebooks grandmaster, and at the moment she's ranked 16th. So we've all benefited in the Kaggle community from Parul's work. She's got really interesting notebooks, and she's been sharing her learnings with everybody for quite some time now. And I've heard her name on many social media platforms, and got to know her personally as well. And she's also got this really nice personal blog, which is called Breaking the Jargons. I really like the name, and she's got everything here. She's got her own article, she's got her own Kaggle profile that takes her to the Kaggle link that takes to the Kaggle profile. And she'll be joining us next week. So last week we had a guest lecture from Tanishq, but Parul will be coming back next week, and she'll be sharing just her journey on how sharing work publicly has been really helpful. And then there's been some sort of bugs. So there's been some sort of questions that have come up from you guys. One of the most common one that I've seen, and everybody sort of asked me about it, is this one. The search images DuckDuckGo is not working, or the search images Bing is not working. So on Slack yesterday, so let me bring up Slack. On Slack, I did share with everybody I did share this link, which basically tells you like what needs to be done. Just use this function instead. Just use this. Sorry, it's this one. Just use this search images DDG corrected. We can go into the details on what exactly is going on, but I've already provided in this thread the whole sort of summary and background on what's going on. So there was exactly a commit that changed this. So that commit is pretty much here. So this commit ID kind of changed the default parameter that due to which this bug is, or due to which there's this error that's coming up. So if you remove the dot decode method, and that should just work. So you can see the difference in DDG corrected and the difference in DDG is just this line of code. So you have a dot decode over here in result. You don't have that here because this URL read now already returns a decoded version of your data. So you don't really need to call decode on it specifically. But we'll go into this. We'll create our own data set. So today we're going to do a lot more coding, and we're going to dig a lot deeper into the source code of FastAI. Something I did want to mention, I'm a bit disappointed about this is, and it's not to point Grijesh, but I've felt that Grijesh is the only person who's come back and he's discussed the questionnaire at the end of chapter 1. So last session I showed you towards the end of chapter 1. There is this questionnaire which has about 33 questions, and these questions shouldn't take long. It should be like 5-10 seconds per question. But I've only seen Girijesh come back, and he's the only person who's been asking questions about this questionnaire. It sort of makes me feel sad that not everybody's doing it, but I want you guys to do it because it will help you. It will really help your understanding. So if you go back and you read the chapter, we want you to do these questions. And we want to discuss these questions throughout the week between ourselves. And you want to make sure that you understand and have answers to each of these questions. We've seen, and I'll be going through the questions today. So we have lots more time today than last week. Another thing is Ravi has brought up is that he was setting up this EC2, and he mentioned that a minimum number of CPUs that he needs to sort of run is 4 virtual CPUs. So he was trying to start with 1 virtual CPU. That's okay. I think that's just an AWS requirement. There's also more things on where if you have only the 1 virtual CPU, so what happens in a deep learning world, or basically when you're using a GPU, is your CPU does a majority of the data processing, and then it feeds that data to the GPU. If you only have 1 CPU, then it's not going to be able to feed data to the GPU fast enough to keep it utilized very well. So it's actually underutilizing your GPUs. What you need is at least 4 virtual CPUs. I usually go with 8 or 16, but even 4 should be fine to start with. And then the last thing I want to discuss is there's been some confusion about whether we want to use FastAI forums, whether we want to use weights and biases forums, and where we're using Slack first, like what's the difference in the 3. When should we use FastAI forums? When should we use weights and biases forums? And when Slack forums? To me, it's really fine. I mean, wherever we want to use, I will share towards the end of today, there will be time. So once we've finished chapter 2, which will be creating a model in production, then I will go into this FastAI forums, and I'll kind of share with you what the differences are, what the benefits are from each, and then I'll let you guys decide. I mean, we can do the comments as last time, that whether we should go from 60 to 90 minutes, and then there was these huge amount of comments on which one to use. So let's sort of do like a popular vote, and we're going to be using this 1db.me/fastbook3. So let me post that here. So 1db.me/fastbook3 will take you, again, just as last time, it will take you to this FastAI Reading Group week 3, which is today, and then we're going to be asking we're going to be discussing everything as part of comments. So that's something that's not going to change. We're going to continue doing this because I find it really easy, instead of having a look at the Zoom chat or having a look at YouTube chat. It's just easy to have it all in one place and still continue having comments. So thanks, Sam, for posting this, and we'll share with everybody on what the benefits are of sharing your V2 projects in forums.fastAI. So with that being said, let's quickly get started with what we are going to cover today. And So we're going to cover all of this today. The last place where we stopped was here. So we're having a look at basically, I showed you how you can create your own data set basically, and the way to do it is to use this download image and to use this search images Bing option. So 1 second, please. Is to use this search images Bing, which is right here. So this was where we stopped last time. So we're going to go ahead from here, and today what we're going to do is we're going to just build on top of this. So by this time, I hope that everybody is able to create their, basically everybody is able to create their own data sets. And this week you should have pretty much created your own data sets. We looked at a simple way to look at the source code of things is just to put question mark, question mark. So last time I didn't go into the coding side of things a lot, but that's going to change this week. So let's just quickly go into chapter 2 production. So I have my thing set up on GCP. So if I import everything, that works. So this was the sort of the search images Bing was the one thing. So you need a Azure key for that, and then you need to pass that key in here, and then you need to say, well, pretty much anything that you want to search for. You could say grizzly bear, right? But what has been noticed is that this is something that wasn't working very well. So there's a substitute for it, which is called search images DuckDuckGo. So let me just, I'm going to Slack. I'm just going to copy this function and let me paste it here. Define search images. So it just defines a function, and I can just say URLs equals search images DuckDuckGo instead, and I can say grizzly bear, right? And I can just say, okay, return the max number of images as 100. And there it is, that returns a number of URLs. So just to be sure that this is working, I can go into the first URL, which is this one, and I can go and let me just copy paste just to make sure. And there it is, that's a picture of a grizzly bear sleeping on a wooden log, which is funny. So cool. So instead of using search images Bing, you can just use this search images DuckDuckGo, and then you no longer need to do results.attribute. So you can just replace that, and instead of doing something like this, just delete that line, which was in the notebook. So you'll have search images DuckDuckGo. You don't need to pass in a key. You can just say grizzly bear, and that's it. And that will return your results. So it returns 279 images for grizzly bears. Cool. Then I can just open my thumbnail. So the next thing you want to do is, if you really want to create your data set, then the next thing you want to do is, instead of using this search images Bing, because we're not using this, we want to replace this with search images DuckDuckGo. And what this search images DuckDuckGo needs is just the term. So there's no need to pass in a key, right? So we take away the key and we just say max images, maybe 100. And then you no longer, because this output will get stored in results. Then you no longer need to do results.attribute. You can just say something like that. And then that will go on. Sorry, there's a path that exists. So let me go rf beers. So basically what I'm trying to say is there's already a path called beers at this, and it says, unless the path exists, you only run this when the path doesn't exist. So that's why this code never got run. So let me just delete that folder. Cool. Now if I have a look, there's no such thing as beers. By the way, having an exclamation mark just means that you're running bash commands or something that you would rather run in a terminal, but Jupyter lets you run these things. It's not a Python, it's not something for Jupyter either. So now I can just say, let me add something called a TQDM, which is just a convenience. And here we go. It's downloading the images. So if you really want to see that it's doing something, I can just do edge top and my CPU is busy. So that means the images are being downloaded and we're done with 33%. So this is just something I wanted to show you on how you can create your own data set. So I could have just gone in and I could have also passed in, instead of doing grizzly bear, black bear, teddy bear, we can also download any sort of images that we want. So you could actually, if I want to create like a tennis ball versus a cricket ball classifier, or I don't know, if you want to go into sport or you want to have anything else, you can do it. So just instead of beer types, just say classifying or classes and just call them something like this, something like a tennis ball. And I don't know if it'll be a difference. I haven't tried this, but you could just say this and that should download, and then you just replace that with this. So that will go and it will download the images for a tennis ball and cricket ball, pretty much. And then something you might be wondering on what TQDM does. So unless you had a TQDM, it won't show something like this. Like now it's showing progress. So it was actually showing me, okay, we were done with 33%, we were done with 66. So that's the main benefit of having TQDM here. Cool. So then at that particular path, if I go to this path, so if I go to the BS path, now I have 3 folders, black, grizzly, and teddy. If I go into black, I have all these images that have been downloaded for black BA. So if I click on one, that's a black BA. If I click on a teddy bear, the image, then that's a teddy bear. There it is. That's an image of teddy bear. So cool. So then this way we have been able to then download images using DuckDuckGo. Then what get image files will do, I'm just passing in this path. So this path is just a path to the folder BAs. So we're running this in Jupyter Notebook, and then what it does is it points to this path with 3 folders, and we're calling a fast AI function called get image files. So I can show you on what get image files is, but if you want to know what get image files is, you can just do a question mark, and then it will show you, okay, all it does is, what this get image files does is it calls something called get files, and it passes in extensions called image extensions. So what is get files doing? So I can just go and say, okay, please tell me what's get files doing. What get files does is it gets all the files in path with extensions. So because we're only looking at image files, then these extensions could be JPEG, PNG. So pretty much if I go and have a look at image extensions, then you can see how there's a list of all these extensions. Pretty much everything that's related to an image. And internally, FastAI is using something called MIME types. So MIME types is what will return just all these extensions. Just in case, that's just an extra thing. So cool. So then get files, all that does is get files will go to this path. It will find a path of all of these files in that folder, only if the extension of that file is belonging to one of those image extensions. So if there's like a TXT or a PowerPoint presentation in there or a PDF, it won't return a path to that. As an example, let me show you. So I'm just going to create a file called cat.txt, and then I can just say get image files in my current directory, and then it's only returning the paths to images. This cat.txt never gets returned. Cool. So then I can go in and I can then pass in this, I can then pass in the path to this BS folder, and I can say, please get all the image related files that are inside this folder or on all the subfolders that are there. So I can just say that and it will return. It will say, okay, there's 259 files. There's the first one is under Beer Grizzly. Then there's pretty much, if I can just go if I have a look at the last 10 files, then they're just beers and black. So it's pretty much gone into the all three of the folders, black, grizzly, and teddy, and then it's returned all of those. It's returned the path to all of those files. Then the next thing is just something called verify images. So see how I'm putting question mark, just to have a look at the source code. There's another way to do it, which is you could actually use VS Code to actually go through the source code. I will show you each of that today, so that today is more practical side of things and less on the theoretical side of things. But I will show you. But right now, because most of you are going to be running this in Google Colab, then the easiest way is just to put a question mark. And if you put a single question mark, it will just return the doc string. So it will just say, okay, verify images just does this. It will find images in all the file names that can't be opened. So that's it. And the last one that I showed you last time is this one. So if you in FastAI, there's this option to click doc. So verify images question mark is Jupyter specific. Doc is FastAI specific. So it will open up this really nice sort of UI, and then you can click on source, and it will also take you to the source of verify images inside the FastAI repo. So that's the 3 ways of doing this. Cool. And then I can just remove a list of files, because then what this does is it will say, these are the 6 parts that can't be opened. So inside this, I can't open this file. These could be corrupt files, or yeah, pretty much they just can't be opened. They could be text files with a JPG sort of extension, but this function is just saying that these are the files that can't be opened. Then the last thing we want to do is we just want to remove them from our path, and that's it. And now we have a data set ready, and we've sort of cleaned it. So yeah, so this is how you can go back and you can create your own data sets. We will have lots more time for questions today. I'm not going into questions right now, but as we go through chapter 2, something I want to say is we're not going to be going into chapter 3 today. I've made a change, a last minute change, which is going to be, we're going to wrap up chapter 2. I'm going to show you each of the steps that I mentioned in the book and sort of show you how I can, how we can do it in Jupyter Notebook. And then I'm going to go deeper and deeper into the source code of some of the things, so you can go back and experiment with these things on your own this week. Okay, so this is where we were. We pretty much left off at this point. So until now, what I've shown you is just a way on how you can create your own data sets. Then from this point on, let's go deeper into what some of these things mean. So something in FastAI, or basically in deep learning, you'll see being talked a lot about is a data loader. So what is a data loader? So you know how I told you we have, say, our data set consists of 100 items. Then you put them in batches. So you say you have 10 batches, batch 1, batch 2, batch 3, and each one of them has 10 items. Then you have your GPU here, and the model is sort of training at this point. Then something is going to pass each of these batches one by one to the GPU. This something that passes these batches one by one to the GPU is called a data loader. Okay. We're going to look a lot more deeply into what exactly a data loader is, or what exactly it does. But in FastAI, you have a class called data loaders. In FastAI, you have a class called data loaders, which pretty much has a train and validation data loader. So that's the, in summary, this is how the source code of this data loaders class looks like. But a data loader class is just nothing but a FastAI clause that stores multiple data loaders objects that you pass to it. So this is a data loader object that will get the batches, and it will feed the batches to the GPU. You can have multiple of these, because if you think of it, remember we have a training set, we have a training, and we have a validation set. So typically what you want to do is you want to have a data loader for training data, and then you want to have a data loader for validation data. So when we had 100 items, we split it into 80 and 20 by a 20% split. So then this 80% would be fed by training data loader, and this 20% would be fed by using a validation data loader. But what this fast AI data loaders class does is that it brings them together. So this has two loaders. The first one is called the train loader, which returns this, and the second one is called a validation loader or a val loader. But you can have as many as you like. Don't think that the fast AI data loaders class can only have two. It can have as many loaders as you want. Okay. So then in fast AI right now, when we did something like get image files, all that it did was it returned a list of paths. So let me show you. So when I did this, get image files, all that this FNs or this file names was just a list of paths. So the first item was a Grizzly JPG, B is Grizzly, then 0083 JPG, which is just the paths to these particular files. Then the question is, how do you turn your downloaded data into a data loader? Because if you want to train your deep learning model, then what you need is you need to convert your you need to be able to convert these paths into a way that can then be fed to your GPU. So for that, what FastAI basically needs is what kind of data we're working with. Is it images or text? How do you get the list of items? So right now, we can get the list of items by using something called get image files. So this is returning my 250 something list of items. The next thing you want to know is how do you label these items, and then how do you create the validation set? So as long as you have the answer to these, four questions, then you can actually pretty much then you're sorted to convert your downloaded data into a data loader. So in FastAI, there's two things that you'll come across mostly. The first one is a data block. So we can create our Bears data block by telling FastAI that there's two blocks. One is an image block, second is a category block. Then you tell FastAI on how you can get all of these items. Then you tell FastAI on how to get all of these items. So the way to get these items is to use this function get image files, which will return that list of paths. Then the final thing you tell is how do you split your data into a training and validation. And then finally, what this get Y is from those list of items, how do you get your Y labels? And then this is the transforms. So we looked into these six, we looked into these six or 5 lines of code previously, but let me again go into them a little bit more deeply. So get image files has, say, about 250 paths. So this is my path 1, path 2, path 3, path 4, and so on. And this path is something like ./images/001.jpg. And this path is something like images/0083.jpg. So something like that. Then what you want to do is from this path, from just this one path object, you need to get two things. One is your image. Second is your label. So what this image block and category block are doing, they're telling you if you want to convert this path into an image, use something called an image block over here. And if you want to convert this path to a label, use something called a category block. So I'll show you on what exactly that means. When we look into the code and we look into it more deeply, then I'll exactly show you what's happening. So that's the first thing. So that's why you have two blocks. The first block is for your dependent variable, and the second block is for your independent variable. So when when you're predicting something, you have your X and your Y. So for example, when we have images of these images as 0.00, oh, sorry, like /images 001.jpg, you have your images as 001.jpg, 002.jpg, so on, 008.jpg. Then you have your categories, because each of these images belongs to categories. So you could have black bear, grizzly bear, and you could also have teddy bear. So then these things on the right, they call the dependent because they depend on X. So X is your independent variable because you kind of predict the Y from X. So the prediction of Y depends on X. So that's just another term of saying independent and dependent variables. So then the next thing that we want to look at, and we can all go deeper and deeper into how exactly this data block is structured in FastAI, or we can look at the source code of everything, which we will do over time. But the next thing is, how do you get your items? So you use this something called get image files. So when you say get, let me show you. So this is exactly what it is. In get image files, when you pass a path, then from that path, it's extracting all the items. So that's what this is. So you can get your items by passing in this function called get image files. Then the third line of code, which is this splitter, is a random splitter. What that means? Is, remember how you have these, you have like these 250 parts of P250. Then you want to be able to split these parts into train and validation, because you want your model to learn from a certain number of images, and then you want to test the performance of your model on the validation set. So what this random splitter will do is it will randomly pick 200 images, so it will randomly pick basically 80% of the images, and it will call it training data. And then it will put 20% and it will call it validation. So that's how this random splitter, that's what this random splitter is doing. So if you have some just 5 numbers like 1, 2, 3, 4, 5, then what this random splitter will do is it will pick 1, 3, 5 in your training set, and then 2 and 4 in your validation set if the validation set is 40%. So then the question is, something that gets passed to this random splitter, is this something called a seed. So what this seed does is that this seed, every time you pass in a random seed, if you pass in a random seed called 42 and you give it a list of 5, basically 5 items, then what this random splitter will do is that every time you'll end up with the same 1, 3, 5 in your training set and 2 and 4 in your validation set. So let me show you on what I mean by that. So let's say I have just the first 5 parts. These are my first 5 parts. And I want to call random splitter, and I pass in a seed. I don't pass in a seed right now. So let's say these are my items. My items are just the first 5 parts, which look like this, right? Then I want to split these items. So these are just this is my whole data set. I want to split these items into training and validation set. Then you can just pass in random splitter. So you can see how the 4th, 3rd, the 0th, and the 1st item ended up in the training set, and the 2nd item ended up in the validation set. So that's just the first part of this, which is this, is just the indexes for the items in your training set, and then this is just the index of the items in your validation set. But if I run this again, then you can see how it's different. Like the last time, item 2 was in validation, but this time these are the items in training. And then if I run this again, then you can see how it keeps on changing. So say if you, the problem with that is if you share this notebook with somebody else, then what will happen is when they're trying to split the items into a training and a validation set, what will happen is their validation set will be very different from your validation set. Um, and a way to avoid that is to pass in something called a seed. So if I pass in a seed, every time I run this, it's going to select the same item as a validation set. It's basically a seed. It's just a way of like, it's not random anymore. I mean, it's okay. I would be digressing if I explained what exactly a seed does, but for now, just understand every time you have a seed. So if you have your 5 items as 1, 2, 3, 4, 5, if you don't have a seed, then your validation item could be 2, it could be 4, it could be 5, or it could be any. But as long as you pass in a seed, it's only going to select, it's going to split the data always the same time. So you end up with the same item in your validation set. So that's the next thing. So that's what this random splitter does. Then the next thing you have in your data blocks is your get y as a parent label. So what is a parent label? So these are things that I want you to, so exactly how I'm showing you right now, this is exactly how I want you to go back and I want you to experiment with these notebooks. So next thing you want to do is you want to check, okay, what's the parent label? Let me check the doc of the parent label. It just returns, it labels the item with the parent folder name. Okay. So if my item, sorry, my 0th item is a path. If I pass in that, so then it labels it as the parent folder. So if you can see, so if you understand this, I think this is crucial to understand. So I had my, so this is, I'm just trying to show you what's going on behind the scenes in Fast AI. So if you have your 5 items, which are all parts like bears, grizzly, and then you have the image name, and then, so let me randomize it actually. It's fine. Then what this parent label is doing, it's because this file 0000090.jpg, it's in the folder grizzly. And this file is again in the folder grizzly. So what this parent label is doing is just finding the parent folder, and then it's returning that. So all of these images are in the folder grizzly. But if they were in a black bear, or they were in basically any other folder, then it would return that. It would return that label. So let me show you again. Interesting. I'm trying to find NP. 1 second, please. Okay, that's more like it. So all I did by using this function and np.random.permutation, if I have, so if I have a list of 5 items like this, then what this np.random.permutation does is it just shuffles it. It just shuffles basically that. So I just shuffled my list of parts and I just selected the top 5 parts in this line of code. So right now, my first item is a teddy bear. My second item is again a teddy. My third item is a black bear. So if I go and do this again, I see. It's because it's an NP array. Never mind for now. All I'm trying to do is I'm just trying to show you if I parent label map. Yeah, there we go. So all I'm trying to show you is basically all I did was I had all my file names and I just shuffled the file names and I selected the top 5. Then the next thing I did was I just found the parent label for each of these. So this is what FastAI is doing internally, is that for this file name, it's saying, okay, this is a grizzly bear. This is how it's the label for this path is going to be grizzly. The label for this path is going to be teddy, and the label for the last path is going to be black. So this is what I wanted to show you. So see how I told you when you have a path like this, so you have a path like this, then there's a way to actually convert this path into an image and a label. So we're converting this path to a label by using something which is called a parent label function. This parent label just returns like a grizzly, black, or teddy category. And then if you want to convert this path into an image, you just open the image using something called a PIL. But that's okay. So that's the basic idea of what exactly is happening in all of these lines of code. The last thing you have is you have something called an item transforms, which is just something that does a resize. So right now, this is something we've touched base on before as well. So you have your 5, or I don't know, you have your 250 parts, but let's say you have just the 5 parts of images right now. Now, each image is going to be a different size. So this image could be something like a 1080 by 1280, and this image could be a 128 by 128. That's not going to work. So if you want to convert these images into a batch, we want them to be the same size. So that's what this resize 128 will do. It will just make sure that each of these are 128 by 128 size, each of the images. And then finally, when you do something like this, you say, so when we did, the beers was just a data block. When we call this line of code, which is beers dot data loaders, and we pass in a path, it converts these into these data loader objects. So as I showed you, what we want to be doing is we want to be able to convert these list of items into something called a data loader that then feeds the batches to the GPU. So this is what this line of code is doing over here, the BS data loader. It's converting basically your list of items into your data loader objects, your train data loader and your validation data loader. So you can actually see the batch. So if we have a look at the batch, if I'm having a look at the valid data loader, then you can see how there's like 4 images. So your path, so you had your path P1, P2, P3, or whatever. Each of those paths have been converted first into an image, and then that path has also been converted into a label. So that's exactly sort of what's going on underneath in FastAI. So this, as already mentioned, this label is coming from this parent label function. Before going down into showing you the various resize methods of what's exactly going on in this part of the book, let me have a look at the questions. So we're going to take 8 minutes break. So any questions so far about what a data block is, what's the parent label doing, what exactly is happening in all of these lines of code? Yeah, Kevin, one nice thing about the search images DuckDuckGo is that you don't need a key. Exactly. So it's free to use, and you pretty much can then just go in and you can just call this function without having an SEO key. There's also a package to download images from Google, which is similar to DuckDuckGo. Okay, I didn't know about this. So yeah, feel free to use any of the packages. There's no expectation to use either one. TIL about TKDM, super neat utility. Thanks for showing us. No problem. If using code, this is a great extension. Yeah. Can you explain what getAttr class exactly does? And how is it advantageous to implement data loaders with getAttr add props rather than just applying train test loaders in the constructor? Yes, I think it's not very relevant for this particular this particular time. I mean, we're just sort of, as a group, we're just learning on what data loaders are. We haven't really seen what getAttr is. We haven't really seen what add props is. So I think this question is a bit far ahead than where we are right now. So we will come back to this question later, though. Is it possible to add a data loader for testing data as well? Well, you pretty much, when you're saying in FastAI, when you're passing in data loaders, so see how you're passing data loader, you can pass in 3 data loaders. So then the first one becomes your training, the second one becomes validation, and the third one becomes your test. There's also an option to say data loaders.test, which will then also create a data. But this is again something that's a bit ahead of where we are right now. What if the random splitter splitting the data does not include images from one category? Okay, that's a really, really good question. So what if I have, so right now, in my 5 items that I had all the 3 categories. I had grizzly, teddy, black, and black. But what if I selected only 4 items? And then I check my parent labels. In that case, I do not have a black category here. In that case, then what you want to do is, instead of, and this usually happens when one of the classes has very few labels compared to the other classes, then sometimes that class doesn't even make it to the validation set. In that case, then what you want to do is, there's something called like a KNN, basically, sorry, not a KNN, a stratified K-fold is what you want to have a look at. So I'll just, I'm sure that's been answered though. This video by Vishnu is a great resource to understand. Yes, I've seen this video. Thank you, Harish, for sharing this. It's really a good video. So let me post this on FastAI. Oh, sorry, on the Zoom chat. Difference between data loader and data block is not clear to me. Okay, I will explain that right now. Can you explain what a splitter is used again? Okay, I will explain splitters. If we have a train and validation set, how can we address it in data block? There's something called like a grandparent splitter, or there's basically ways to do it. Like if you have your folder structure, this is a very easy thing to solve this question, but we will look at an instance of this very, very soon. So I won't touch on this right now, but typically you want to look at something called a grandparent splitter. Okay, so then the last 2 questions. What is the difference between a data block and a data loader? Let's touch on that. So this is what the data block is doing, basically. All you're saying to the data block is, you're passing in some things. You're passing in the 2 blocks. You're passing in a way to get items. You're passing in what splitter you're going to use. You're passing in on how you're going to get your categories, and then you're passing in what your item transforms are going to be. Right now, you're not actually doing any of the computation. Okay, it's just think of it this way. A data block is just a map. So if I want to go from A to B, where A is my list of items. So this is my list of items, and I want to create my data loader. Then the data block, this thing, is just a map. So it's just a map. So it's a map that's showing you how you can go from here to here. So you haven't really created your data loader. A data block is just telling you that, okay, for this kind of data set, for this kind of beers classifier, these are the kind of things that you would need to be able to create your data loader. That's exactly that is. So it's just a map. It's just a template. But the actual creation of the data loader happens here. So when you say, so this beers is a data block, remember that. So this beers is a D block. You're creating your data loaders basically by saying data block dot data loaders, and then you pass in the path. That's when these data loaders sort of get returned. So this is something that you should remember, is a data block is just a map or a template from point A to point B, point A being your list of items and point B being your data loaders. Then when you call data loaders on it, that's when the actual thing gets called. Cool. That's time. Let's move on. I think that was most of the questions. We'll cover the other ones after. Oh, sorry, I missed this one. What is splitter used for again? So Corinne, if you remember, what we had to do last time is we want to be able to split our data into training and validation set. So in a model, you want to train your model on a training data, and then you want to test the performance of that model on a validation data set. So what this splitter is going to do is it's a way to split your list of items into training and validation. So what that means is, one last time, what that means is, if you have like a list of items, say 100, right now the data block doesn't know on which of these should go in the training set and which of these should go in the validation set. The splitter is what will tell you. The splitter will tell you, okay, out of these 100 items, given that you want to have 20% of the items in your validation set, out of these 100 items, this item, this item, this item, this item, and then whatever the 20 items are, these randomly selected 20 items are going here, and then the 80 items are going here. That's if you have a random splitter. But if you have any other type of splitter, there's like different types of splitters in FastAI, but right now all we need to worry about is this random splitter. Then all it's doing is it's just splitting your data into training and validation sets. So that's exactly what you need to know. I hope that helps. Okay. So right now, what we had a look at was this resize 128 being passed. But if I go into I see. So basically my first so this is, I showed you how we want to be able to convert this path into then an image that you want to use to train your model, right? So there's a library called PIL image in Python that can then open these images. So if my image looks something like this, it's a really big size, right? So if that's my image, then the size of this image is 1920 by 1280. But remember, what we want to do is for each of these items or for each of these images, we want to resize them to a particular size. So there's a function called resize. And I can just say resize to size 128, and I can pass in the image. This seems to be a small problem here. This should work. That's okay. I will skip this point for now and show you exactly through the examples that I have already. So when you have this resize 128, what this is doing is it's taking all of those sort of grizzly and teddy bear images that are of really big size, as I've shown you here. So if I go and have a look at this image, and each different part would have a different image size, right? So this is a really big image, and what this resize is trying to do is it's trying to resize it to a particular size of 128 by 128. There's different methods on how you can resize. So look, imagine this, right? If your image is that big, if this is my teddy bear image, 1280 by 1920, and I want to be able to resize it to a square. So this is not a square. One of the sides is much bigger. And I want to resize it to a square of 128 by 128. Then one way is I can squish it, right? I can squish it, which then looks like this. So you can see how in this case that grizzly bear has been stretched. So you can see from this image that this looks a bit weird. Like, I mean, there's something that we're missing out on. Like, the objects are now warped, or the objects now look different than what they actually are. So that's the first way of resizing. The second one is you can pad an image. So say if you want to resize this to 128 by 128, then what you can do is you can pad your image on these sides. So this is also 1920, right? Because you can add a bunch of just black border on this side. So then this becomes a square of 1920 by 1920, and then that can be resized to 128. But you can see how now adding these black borders. So when you're going to pass this image to your model, what's going to happen is that model is going to think of these black borders as information. And if it's going to think of these black borders as information, then it's going to lose accuracy, because you're actually not passing in your image, but there's actually all these borders that are being passed. So those are the two methods that are there. But again, these are both methods aren't the best. These are good to create model baselines, but they're not the best, because why? If we squish or stretch the images, they end up as in unrealistic shapes. For example, we saw this bear. That's an unrealistic shape. That's not how a bear looks like. Or it can be like even this one. It looks a bit stretched horizontally. So that's an unrealistic shape. Or if we add borders, then we're adding this extra information. So both these are suboptimal. They're not the best way to do this. The next thing you could have done, right? The next possible thing that could have been done is if I have my image like this, as already said, if this is 1280, this is 1920, then what I could have done is I could have found a square inside this image like this, and we get rid of all the other image. This is called as cropping, right? Image cropping. We do this anyway in our phones, or that's just image cropping. But the problem with this is you're actually missing out on a lot of other data. So what if the bear was like this, but you only have the lower body and not the upper body of the bear? But this thing is called as a random crop. So it's just a way of cropping. But in practice, what we actually do in deep learning is when you're training your models, what we do is we do something which is called a random resized crop. So say you want to train your model for 10 epochs, right? In the first epoch, you find this crop, which is the size. So even if your bear looks like this, in the first pass, the model gets to see the head and the body. When you're doing the second pass, your crop comes from here. So now the model already knows what a head looks like, and then it gets extra information about the feet of the bear. And then finally, you have, say, your third pass looks like this. In that case, now the model has this extra information about how the hand sort of looks like on the how particular this side of the bear looks like. So this is something that this is how a lot of the models are trained in deep learning in practice today is that you have something called a random resized crop. The benefit of this approach is, your images, they don't either become too sort of stretched, or they don't sort of become too small. You're not always cropping the same side, so you're not always losing out information. And then over time, as you go over and over these images, and you do multiple data passes, then what you see is the model will actually see each part of the image every time. So say in 10 epochs, the model would have seen each part of the image. So it still sees the full image, but just in parts. And this is what random resized crop looks like. So if you have an image of a teddy bear, so say the first crop gets this image. So right now we're missing, say, we're missing some context on the upper side. But then the second random resized crop looks like this. The third one looks like this. So now you get the feet, and then in this one you get the feet and the hand, and you sort of miss the head. So this is like just a way or an example of what random resized crop looks like. So that's just that was just what all these 5 lines of code basically mean, and in data loader, and then what there's different ways of sort of resizing and resize cropping. The next thing I want to touch on is data augmentation. Okay, and this is important. I think this is something you would have heard everywhere in deep learning is data augmentation. So what data augmentation basically does is you have an image, and say this image looks like this, right? Then when you're in a real world and you're trying to train your deep learning model, it's not always going to get this same image. This image, when you see it in real world, this image could be rotated like this. It could be, it could be horizontal. It could be vertically flipped. Like you'll see, this is just a bad example, but say if it's an example of a basketball line here, right? Then you can have like all these different images or all these different ways. Like it depends on the camera person and how the camera person takes the picture. It could be blurry, it could be different contrast, it could be different image. So then this process of creating these multiple sort of images from the same from the same one image is called as data augmentation. So you see, you have your teddy bear, and the typical data augmentations that you have are something like rotation, flipping. So flipping is just, if your image is like this, you just flip it to your right, or you flip it vertically, so it's reverted. Warping, which is just if the image looks like this, then you either go like that or you go like that. So it's just like sort of a different angle. So this is a warped image of a teddy bear. Then you can change the brightness, you can change the contrast. So this is helpful. How is data augmentation helpful to deep learning models? Is, we talked about overfitting last time. So overfitting can only happen if you see the same image again and again and again multiple times. That's when the model can learn, okay, a teddy bear, a yellow teddy bear looks exactly like this. Like if I feed this image to the model 10 times, then the model is bound to overfit on this particular image, and it won't be able to generalize better. But when we add data augmentation, then in the first epoch, the first time the model will see something like this. Say the second time the model will see something like this. The third time the model sees something like this. So every time the color, even though it's the same image, we can create multiple of these images, and that's this idea is called data augmentation. Okay, we are towards the end. There's not much left now. Now we so this idea of data augmentation, that's the main covered thing. So we can now pass in as a batch transform to your data loader, basically. What does that mean? Why are we passing this as a batch loader? Typically, so you had your, say you had your list of 100 items here. Then you create your batches of 10. Then you want to do all these rotation, all these sort of flipping of in batches. It's just a way to save computation, and it's just computationally better rather than doing it on each image and then you create your batches. It's just a better way of doing it on the batches first. Great. So then I can just create my base data loader passing in these augmentation transforms. So remember, anything that changes the original image is called a transform. So I can pass in these aug transforms, which just says, okay, my data loader now has data augmentation in it. And then the next thing that we do is, this is something you've all seen before, is we just create a learner. We say, I want to create my convolutional neural network. The model architecture is called ResNet 18, and I want to my metric is error rate. So I want to monitor my error rate. So when I fine tune my model, so let me show you in the notebook. So I'm just running all those lines of code again. Okay, this is the point where the model is training. So meanwhile that's running, let's continue forward. So something that we have is called the confusion matrix. So in a way, once your model has sort of trained and sort of learned how these different beers look like, then what you want to be able to do is, you want to be able to tell where did my model go wrong. So that's something is called a confusion matrix. A confusion matrix will tell you where did the model go wrong. So the best way to interpret this is, you want all your items to be on the diagonal. Okay. So if there's 41 here, that means that there's actually 41 bears, and the model has also predicted. So there's 41 images that were actually bears, and the model predicted them as black. But if I look at this one, this means it actually was a grizzly, but the model predicted as a black. So this is something that this is how we can see, and it's helpful for us to know when we put the models in production. This is helpful for us to know that this is where the deep learning model got it wrong, or even here that it actually was a black bear, but the model predicted as a grizzly. And going back to this, when I was showing you this learn equals CNN learner, passing in the model and the metrics equals error rate. So when you pass in an error rate, then you can see how in the first epoch, it says that my error rate is 18%. And the error rate goes down and down and down until it is 0%. So this model particularly is able to classify all of my images perfectly. 20, so it has 20 images which are black, and it also predicts them as black bears. There's 18 images which are grizzly bears, and it predicts them as grizzly bears. There's 12 images which are teddies, and it predicts them as teddies. So that's the main sort of thing on how you can then create your model. But the next thing you want to do is, you can actually use a model to check. You want to check your model on, okay, where did the model go the most wrong, right? So when you FastAI has something called as an interpretation plot top losses. What this top losses does, a loss, remember, a loss is something that will be high when your model is wrong. So that's when the loss will be high. So when you have your loss as something like, so these 4 labels are just the actual class, the predicted class, and then, oh, sorry. I think the first one is not the actual class. The first one is the predicted class. So the first one is predicted. The second one is the actual class. Then this is your loss, 1.37. And this is the probability that the model says it's a grizzly. So the model is 70. It's saying with a probability of 0.74 that this image is a grizzly. Now, actually, if we have a look at this image, so remember from the classification matrix, there was one image that the model got wrong. If we actually have a look at this image is actually that of a grizzly bear. So it's not even a black bear. So the label is incorrect. So this way, we can actually do a lot of data cleaning, because then you can compare the predictions of the model to the actual labels. And then you can see, okay, in this case, it's the label that's incorrect. And in a real world case scenario, you have lots of these places where the labels could be incorrect. And this is a good way of making sure that you can clean your data using this method, using this interpretation plot top losses. So yeah, so the intuitive approach to do data cleaning is to do it before you train a model. But FastAI and Jeremy and Sylvain sort of in this book have shown us that how it can be really helpful to do the actual cleaning after you've sort of trained your model, and then you compare the predictions of the model with the actual labels. So this is just going into data cleaning from here on. So if you see in data cleaning, FastAI has something called an image classifier cleaner. So if I go in my notebook, so this is how this cleaner looks like. What you can do is in this cleaner, it will show you all these different images. So in this example, it's actually showing you an image that is both a grizzly and a black bear. But in the data set that we've downloaded ourselves using this DuckDuckGo, there's no dirty images as such. Like this even, the second image, that of a grizzly has 2 grizzly bears, so it's fine. But in this particular data set that Jeremy and Sylvain were working with, there was this particular image with 2 with a grizzly bear and a black bear. So what you could have done is you could have just gone here and you could have said delete it, or you could have changed the label of this image to say it's a basically black image. So this is how this sort of image cleaner or image classifier cleaner will work. It's using the trained model predictions, and it's sort of can be then used to clean your data set. So when you creating your data set using the DuckDuckGo, please don't forget to use this cleaner, and don't forget to interpret the interpreter's plot top losses method to then see losses, and then pretty much see the actual model predictions. So that's the main sort of things that I did want to cover. So that's how I know we've covered a lot today. There's a lot that's been covered, and there's a lot of information that's been dumped on you. But that's okay. When you go back, just read this whole chapter slowly and steadily, and then all of this will make sense. But before, now the only thing that we're left with today is just how to turn this trained model that we have that can tell grizzly bears from black bears, how do we convert this into an online application? So this is something that we're going to do now, but I'm going to take 4 minutes of questions, if there are any. How can we create a stratified validation in case we have a class imbalance? Well, this sklearn has stratified splitters. FastAI has a stratified splitter as well, as far as I remember. So the best way would be you search something like stratified split, stratified split, and you just say FastAI. So see how this is forums. It'll take you to the FastAI forums, and it'll show you how you can do stratified labels sampling. If FastAI library does have equal replacement for k-fold for dealing with class imbalance, I'm sure there is. Yes, it's been answered in the forums again. So yeah, before asking, like just have a look in the forums. Most of the questions you'll find have answers to that already. When do I get tensors out of the data loader? Okay. Again, so what happens is you have your items, right? These items are being resized. So all of them are now 128, 128, 128. Then they get converted to tensors. So each of these get converted to tensors. And then that's when they get stacked. So you have a tensor of 4 by 128 by 128. So then your data loader, so this becomes your first batch. The same thing happens for the next 4. So you have another 4 by 128 by 128 tensor. So when do I get the tensors out of the data loader? Pretty much every time the data loader is returning tensors, but there's a point where each item, after being resized to a specific size, that's when it gets converted into a tensor. What will happen if the image does not belong to the sample? Okay, that's called outer sampling. We're going to cover that next. That's a really good question. Is random splitter needed when you have both training and validation folders? No. Again, you want to use a grandparent splitter, or you want to use like a folder splitter, that you want to split your data set based on folders. So the question for context for everybody, the question that's being asked about the folder structure, it's just this. So instead of having all my items in a particular folder, in which case it's called beers, what if I have beers and then I have two folders, train and val, and then train has all these sort of 100 images and val has, say, 20 images. In that case, how do I do this splitting? So then how do I split based on these folders? I think it's called the grandparent splitter, but yeah, that's the one. I can get back to you on what exactly it's called in FastAI, but I'm sure there's a way, like you can just have a look. Yeah, there it is, grandparent splitter. Okay, you can't use a grandparent splitter on like indexes 1, 2, 3, 4, 5. So I've got to explain what a grandparent splitter does. I'm confusing myself with a grandparent splitter, but don't worry about the grandparent splitter for now. I think I've said, I will give you context on where each of these splitters gets used, but give me a day and I'll get back to you with where, which splitter will get used at which point and how you can do this splitting based on the folders. Oh, what is the difference between splitter and valid percentage when we were using this? Well, internally, when you were calling image data loaders.from name function, FastAI was creating a splitter for you for that particular valid percentage. So in that case, you didn't just have to specify a splitter, but because now we want to show you on what exactly is going on step by step, that's why we have a look at what splitter is. Will it matter if at test time the images are resized? No, it doesn't matter if they're resized using the same method as training, but it is recommended that that's what the case is. Again, this is something that we are skipping ahead a little bit, so I will answer that in my own time afterwards. It's not relevant right now. How a random resize crop makes sure that the entire image is seen by the model. So as I said, because you're making multiple passes over that image. So that's why it's seen by the model. The whole image is seen by the model. So for example, here, when you have this whole image, the first crop is here, the second crop is here, the third crop is here, and then the fourth crop is here. So every time, because you have a different crop, the model actually ends up seeing the whole image. I think that's been asked before. So the question is, when we're passing batch transforms in FastAI, then is the same type of augmentation being applied to all images? I would say so, but I'll have to double check, because there's no way to have, if you're in a particular batch, then yes, this in a way the rotations and but I'll have to go to double check if FastAI does something more interesting. But my answer would be yes for now, but I'll get back to that question. I'm skipping this one for now because we already looked at fine tuning, but we will look into model training a lot more. Would it make sense to add borders to images during item transform in training? Okay, these are all really good questions. I was just thinking if there's anything that's so far, these are all questions that build on top of what we've looked at today. But I was just more looking at questions on, okay, I didn't understand this part of what we looked at so far, or I didn't understand this part of what we looked at so far. But it looks like everybody's understood what we've looked at so far, because nobody's asked me to explain a particular step again. So that's good. Okay, so then the next thing and the last thing that we're going to do today is called, we want to turn this trained model into an online application. And this is something you're all going to do this week. So we're going to spend time on this right now. And we're going to use this model for inference. So let me show you on how that can be done in code instead of reading the book. So the first thing, so by now, when we have this, we have a learn as a CNN learner, right? And this learner has been trained. So remember how a model. So if we have a model, it gets inputs, and a model has weights. So when a model has been trained, these weights are what we want to store for the model. So in this case, when you have a 0% error rate, this model has been trained and it already has these sort of weights that are the best weights for this model. So what we do is then when we say something like learn.export, then in my current path, it creates a file called export.pkl. So basically what this function has done is that it's taken the learner, it's taken those weights, and it's dumped all of it in a file. So then you can actually share this file now with anybody. I could share this export.pkl file with you, and you could call load learner for this export.pickle file, and it will create my learner object again, and it will be using the same weights that we have so far. So this is how you can actually convert your model into a file that can then be shared with a lot of people. And then I can finally call predict, and you can see how the learner still can predict this image of a grizzly, and it still has the same vocab, which is black, grizzly, and teddy. So what we're doing, let me explain what we're doing. So first we had a learner, then we put it in a file. So I'm going to call it export.pkl. So I trained my model and I stored everything that I needed in this file. Now this is the file that I can share with a lot of people, or I can share with multiple people, or I can then, when I want to call inference, or when I actually want to make the predictions, then what I can do is I can say load learner, and I can pass in the path to this file, which will create this learner object. And then I can then call prediction learn.predict, just as this model was trained just now, and it still keeps the best weights, and then I can then call predictions. So look at this sort of scenario that I created to help explain what's happening. I don't know about, well, different companies have it differently. But just as an example, say I'm a data scientist or an ML or an AI scientist. There's like different names for these things in different companies. So I'm sitting here and I trained my model. So I wanted to create this. Bayes classifier. So I trained my model, and then I dumped it into this artifact called model.pkl or something. It's just a file name. Then what I did, my model is ready. I'm a data scientist. I've done my model training. Then typically what I do is I will take this file and I will give it to somebody who's responsible for putting this model towards the customers. So then if there's like all these customers here, they should be able to interact with this model, right? Then someone like a data engineer or someone who's responsible for making sure that this model can then be then call predictions on basically the users can use it to call predictions. What they do is they will keep this file in an environment that has all the dependencies. By dependencies, I mean this environment, if you it has all the libraries, like it has Torch, it has FastAI, or basically everything that you need to be able to load the learner. And then a user could pass an input image, which could be an image of a teddy bear. It could pass an image to this particularly file, which or this learner, and then it will return predictions as usual. So this is the sort of the way things get done in most companies, and usually this person could be the same who's responsible for training and then also putting the model in production. But basically, putting a model in production in simple terms means that then the users can use this model to call predictions. So what's the difference in training? So what's the difference in training and inference? Inference just basically means when you're not training your model anymore and you're just calling predictions on it. So we're going to be converting this model and we're going to convert this into an app. So the first thing that we need to do that, there's something called IPy widgets. Or is it called? Yeah, it's called IPy widgets. So there's something called IPy widgets. So this IPy widgets has been imported here. From those widgets, I can create all these different buttons. So I can create my upload button. And then right now, I just passed an image path to this basically button. I just said that the image that I've uploaded is this particular image, this grizzly image that looks like this. Then on my learner, I can call predict passing in this image. So what that will do is see how it returns the prediction. It returns that the prediction is that of like this image has been predicted as a grizzly bear, and the probability of prediction is 0.999. So the model's really, really confident that this is a grizzly bear. Then finally, I can just convert this process that I did manually of passing in an image and then the model calls predict. I can then convert this into a button called classify. And on this button, I can say, if I click this button, then call this function. What this function will do is whatever image I've uploaded to my upload button, it will convert that into an image that looks like this. So this image, it will convert it into an image. Then it will clear any output that there is, and it will display that image. And finally, it will call prediction on this particular image that I've uploaded. And then it will say, okay, as a label, show this. Like, this is my prediction, this is my probability. So let me show you on what I mean. So see that? That's what it's done. It's converted this whole thing into an app. Like, you can just use Jupyter to create this really small app. And this is something I want you guys to go back and do all of this in this week. Is all of you should have a single app that you're proud of that looks something like this. And then I can just go in and I can upload an image of, I can just go in and I can upload an image of a grizzly bear, and I can click on classify and see what it does. It says, okay, that's a prediction is grizzly and the probability is 100%. I'm 100% confident that this is a grizzly bear. But this is, again, in a Jupyter notebook right now. So what you want to do is, you can't really share this Jupyter notebook with customers, right? You want to be able to convert this into a real app. For that, there's two libraries. One of them is called, the Voila is a library that does this. And then if you just call these two lines of code, it will convert this into an app. So let me show you. So all I did, I copied all of the stuff that I had, basically just from here all the way to here. I just copied all of the stuff into a new notebook, and I'm just running this again. It's the same thing, right? And this is my output. So if I click on that, when I install that Voila application, then I can click on this. And what that will do is it will convert this thing into an application. So now I can share this, because right now I'm running this on my local host. If this was online on, like, say 192.168 or some HTTP URL, then what you can do is now you can share your app with friends, and they can all come in and they can all upload their own images. So if I go in and upload another image of a grizzly and I click classify, well, it works. So I can download another teddy bear image, or I can upload that. So now I've sort of converted this model that I had of a grizzly and a teddy bear classifier, and I've converted that model into this nice looking app, into a very basic nice looking app that looks like this. It just has like 4 or 5. It has some buttons that iPad widgets we used to do, and then it uses this voila to convert this Jupyter notebook, and it serves it at this URL voila render. So then homework for this week would be taking this sort of exercise and then going back and converting everything. Like you could have your own data set. Say you're interested about a guitar, or you're interested about I don't know, you're interested about music. So then you could have all these musical instruments, and you could have an app that does a music instrument classifier, and then you could also have an app that somebody in a FastAI student previously, what they did was they uploaded 10 images each of their cousins. So he had like 16 cousins, so he uploaded 10 or 15 images each of the cousins, and he created an app that was called a cousin classifier that then his partner could use to classify which cousin is, like, what's the name of which cousin. So she could just take a picture, upload that image of that cousin, and then it will tell you the name of that cousin. So there's like all these different things that you can now build. And this week, don't come back next week if you haven't built an app like this. So then the next thing that comes, and I'm going to go 10 minutes over, because there's more stuff that I want to cover today, and I'm not done yet. So it's better if we cover this today rather than leaving it next week. So right now we've converted things into an app already. So this is done. Then the next thing is deploying your app. What deploying your app means is, say you don't want to use a GCP instance, then what FastAI suggests is there's an app called Binder. So let me see if I can find it. So there's this app called which is in the notebook. You can go to this URL called Binder, then just go create a GitHub repository. So you'll have to check what GitHub is, and then if you go create a GitHub repository, I created a recent GitHub repository called beer classifier, and then I uploaded this exact. Basically, I uploaded this exact Jupyter notebook over here. So this is the same notebook. And then I can pass in the URL of this GitHub repository over here. And then the next step that's mentioned is you just change the URL to open to this voila render, and then the name of the, so I can just say beer.ipynb, and I can click on launch. So that will then launch this into an app classifier, and it'll give me this URL. So if I go to this URL, I can share this URL. It doesn't want to do it for me right now. That's okay. It's just a small bug that I'll have to fix later. But basically, then what it will do is it will convert this into an voila app that will look something like this. And then you can share this with anybody in your family, or you can even go to this URL from your phones and you can upload images and you can classify those images. So this is something you want to do this week, is you want to create your own data sets. You want to use the FastAI cleaner to clean that data sets, and then you want to be able to deploy this app to Binder. So that's the most of it. That's pretty much the most of it. I do want you to go back and read the 2.4. So we've covered so far. We won't be coming back to chapter 2, but have a look. The rest of the chapter 2, there's mostly theory, and there's mostly interesting patterns. Like I've shown you the major bulk of what there is in chapter 2. I've shown you exactly how you can convert things to an app. And what I want you to do is then go back and read all of this, all the titles and everything, especially things like how to avoid a disaster. Because when you deploy your app, you need to be able to make sure that it can still classify things. There's some things that you really need to be able to think about. And this, go back and have a look at this part, and then answer the questionnaire. So there's like these 27 questions. You should be able to answer the 32 questions from the first chapter, and then you should be able to answer the 27 questions. Okay, then last thing I want to discuss is now that we're all doing projects and we're all doing, sorry, I'll go to questions first. We're just going to have a look at if there's any questions so far about what we've discussed. As I showed you, Mohit, you can pretty much say doc, or you can say question mark in Jupyter Notebook. But if you want to do it in Visual Studio Code, I don't have it connected, but let me do it now. I'll show you how you can do it in Visual Studio Code. 1 second. The easiest way is, say you want to learn about this load learner function, call doc, pass in the function name that will tell you what exactly this function does. You can click on show in docs. So it will take you to the FastAI documentation. FastAI has really wonderful documentation. It will show you exactly, it will show you, it will give you what all the other basically functions are that get called. And then you can also have a look at the source code from here. But something I like to do is I like to connect to this using VS Code, because I'm on GCP, and then I can open my folder. So then I can open the FastAI repository. I don't read much of the documentation anymore, but when I do, I do use the doc. But say I want to look at this load learner function, something I do, I just search for this load learner. And then that takes me directly to this function, so then I can have a look at what exactly is happening. So for example, one thing I did do today is I was having a look at this verify images function. So when I went into verify images function like this, I can see that all it's doing is it's calling the verify image function parallelly. So I can click on this, and then I can see, okay, all it's doing that it's trying to, there's a path to it, and it's trying to open that path in a particular mode, and that's it. It can see if it can load it and can open it, that's it, it turns true. So that's just how easy things get when you're using Visual Studio Code, or any other editor of your choice. Assume the total number of items is 105 and the batch size is 10. How will the take care of the last 5 items? So there's an option. Either you can do drop last, which will then the last batch size would be 5. That's okay. I mean, just the GPU will get 5 items. Or the second option is you don't drop the last items, and in that case, it will pick the 5 items randomly from the remaining 100. I think there's like a circle loop as well. Like you can have the first 5 items. So that's just a basic answer. In GitHub, we'll need to have model and requirements to deploy it via binder, right? I'm not sure. Something was failing on my end when I tried to, but I'm having a look at. So FastAI has Beer Voila app. So FastAI has this Beer Voila app. So if I click on this binder, it has this export PKL, which is that thing, and it has a requirements.txt. So it does seem right. You do need the requirements, the txt and a model.pkl. I think I made a mess of it, but then you can see how it's now creating this. It's now creating this app. So it'll take a few minutes, but have a look at this repo. Let me share this here. Have a look at this repo. It's the template that is used to create this binder Grizzly app. But I'll also post this in discussions going forward. How do you search for functions in VS Code? There's a shortcut called Control-T. You can view the FastAI source code directly in VS Code in your. Yes, thank you. That's a good point. This, of course, works well for the repositories as well. Yes, that's a good point. There's also, is this opening code spaces, I believe? Let's see. Yeah, there's this is actually quite handy. There's also GitHub code spaces that you can do that will open it in the browser. Thanks for sharing this, Ravi. Do you recommend setting up environment using Conda or use of notebooks so that web applications can be made for deployment? What's the question again? So do you recommend setting up environments using Conda or use of notebooks? For the notebooks, you'll need an environment anyway, unless you mean like deployment. For the test or for the small applications that we're going to be building this week, notebooks are completely fine and capable of taking care of all your needs. Okay, so then this brings us to the last thing. The last thing that we want to discuss, I will post it here and you can start commenting. Where do we host our discussions if not on Slack? Okay, and the options are basically weights and biases forums or FastAI forums. So now what will happen is you will go back this week and you would have created your own sort of application that could be any classifier that you're interested in. You would have created your own data set. And this is a really good time to start blogging. If you're not blogging yet, this is a really good time to start blogging. And Parul's going to come next week and she's going to share all her experiences on why you should blog. But basically then there's two options. Like you can share, you can continue sharing your work on Slack. But the problem with Slack is it has like this 10,000 limit of it has these 10,000 limit of messages. And what's going to happen is that then those messages will get lost over time. So if somebody's coming back and they're doing these Fastbook lecture videos, 6 months after, they won't be able to have a history of these messages and they won't know what we are referring to. So the easiest way, there's two options then, and I've been sort of considering which one to go for. There's pros and cons for both. I mean, being a part of the FastAI forums is really handy. But then the question is, where do we get the fast books? So if we go to part one, then the options here are, see, there's all these things that you have a BA classifier, but then there's this category called study groups. So I could create a new topic over here called Fastbook Study Group. But then we would be, or we could go in this deep learning category and we could go, deep learning only has latest. Okay, so deep learning does not have study groups category. So we will have to go into part 1 2020, then we will have to go into study groups, and then we'll have to create a new topic. And then that's where all our discussions would be. So we'll be sharing the space with a lot many other people, with a lot many other study groups and a lot many other people, which has a lot of advantages. The advantages are, the advantages are that you get this community and this environment of other people who are doing the same things as we are. But there's a disadvantage that things would be a little bit inside the forums. Like they're not, like you're not going to be the exclusive 70 people or 100 people who are sharing your work and then it automatically gets highlighted. So then the other option is we go to the weights and biases forums, which is this place. If you go 1db.ai/fc, and if we go into these forums, then I can start a discussion called share your work here. So sorry, one thing I should have mentioned is there's another share your work. It should be somewhere in forums. Let me Google it. Let me check for it. Sorry, share your work. So there's a multiple categories of share your work. So that's what I'm talking. Like if we go in the forums, there's so many categories of different things. That there's a lot of other people have shared that work, and you can go in and you can share your work. Or on weights and biases forums, then it's going to be highly exclusive to us. So we could have, you could have in and you could have a discussion and you could have share your work that I can then easily look at. Because if we all go into the forums, then things would be, I would imagine things would be, small things would be at different places. Whereas in weights and biases forums, if we go here, then it's just exclusive for the group, for us. And personally, I'm more inclined, actually, I'm not inclined. I'm thinking I can't come up with an answer on which way to go. But I think having that exclusivity, personally, I would have preferred that. But to me, it really doesn't make any difference in the sense on where we should go. So if you guys can come in and you can answer, you can come in and you can answer to this thread, that would really be helpful. So then I can find and I'll know like where does everybody wants to go. Are you guys there? Could you please post? I really request, if there's like 60 of us right now in the call, can we please all post where we want to move ahead with our journeys? And that doesn't mean that if we're in one DB, that doesn't mean we can't be in Fast AI. We can be in a bit of both, but then that's again the same problem. So we need to be at the one place, whichever it is. Okay, there's a split so far. That's not what I expected. Yeah, there's also Fast AI Discord for those of you that don't know. There's a Fast AI Discord. So let me show you Fast AI Discord. But Fast AI Discord is not so much for sharing work. It's more for chit chat, and it's more for. So if I go in Fast AI, and then there's chit chat and there's stuff about Fast AI work. So you can see Jeremy's there, by the way. Jeremy's there on the forums as well. But there's Fast AI is more about development. It's more about live coding sessions, and it's more about the general things that are related to Fast AI, and not so much about the projects. The forums are a better place for. Okay, it looks like 1DB is the preferred option so far. That doesn't mean you shouldn't post in the Fast AI forums, but let's make a discussion. Let's go Fast AI. Let's go 1DB forums from here on. And we are going to move away from Slack. So something that you're all going to do, I'm going to create a discussion post here, and I'm just going to say, actually, I'm not going to create a discussion post. All we're going to do is all we're going to do from this point on is when you come here, we come to the forums, instead of commenting, or because if you comment, I get notified, so that's also fine. But then if you have any question that's related to the fast book, come here and start a discussion. So anything that's related. So instead of asking on Slack, if you do ask on Slack, I will ask you to repost on the forums, we want to keep it long term. And then if there's projects that you're sharing, if there's work or projects that you're sharing, there's experiments that you're sharing, or all that stuff, we can discuss it on the Weights and Biases forums, but then also let's tweet about it, let's blog about it, and let's also share it on the Fast AI forums. So let's do a bit of both, but let's keep the Weights and Biases forums more exclusive for us, between us as a group, because we're going to be going forward for the next 15 weeks. So let's keep it more exclusive between us, and we answer and ask questions and have all these discussions at this one place. And then I'm going to be using this one place to highlight your work, to find your work. But feel free to also post it once things are ready. Post them in the Fast AI forums on, okay, look at this is what I did. So anything that's Fast AI specific, library specific things, we will take it to the forums. So I think that's yeah, everybody's saying Weights and Biases. Okay. So thanks for that, guys. I think this is it for today. I will announce it next week on what's happening and these changes on how we're going to be using the forums only for these discussions. But going forward, that's what we're going to do. So if you do post in Slack, I will ask you to repost on forums. So thanks for today. Thanks for joining. As usual, feel free to ask me questions. I'll be there throughout the week answering all your questions that you might have. The second thing is, unfortunately, I won't be around for the informal catch up today. I've got to be somewhere. So if you do want to just post in Slack, and I will still create the meeting so you guys can talk to each other. But thanks for today, and see you guys next week. Bye.